Supplement number 12. Carlos can run a mile in 6 minutes. Kevin can run a mile in 8 minutes. If Kevin goes out to practice and start a minute before Carlos starts on his practice run, will Carlos catch up with Kevin before he reaches the mile marker? Assume a straight track and average speed. Okay, so what is our first step? Visualize the movement or our moving object, which is Kevin and Carlos, running a straight track with an average speed. Okay, it says that Carlos can run a mile in 6 minutes and Kevin can run a mile in 8 minutes. That statement is their rate of change. Okay, so but Kevin goes out to practice and start a minute before Carlos start. It means that Kevin already start a minute before. A minute before. He he ran in advance. Okay? In short, he Kevin ran in advance compared to Carlos. Okay? So you already have an advance. This is 1 minute. 1 minute advance compared to Carlos. Then, Carlos start on his practice run. Will Carlos catch up with Kevin? Of course. Before he reaches a mile marker, in this condition, when Carlos catch up with Kevin, it means that at this point, at this point of time, the time of Kevin and the time of Carlos are, yes, equal. Because they catch up with each other. Okay. Okay. Now that the movement or object is clear, Kevin is ahead. He runs ahead compared to Carlos. Now, let's get our TRD box. Okay. If we have our TRD box, we all know that we need to complete the details of TRD box. Let's be clear that the unit of our TRD box is in our, this is mile per hour, and this is in mile. Okay, so our object, the moving object, is Kevin and Carlos. Okay, so Kevin and Carlos. Okay, so it's already there, but we need to, yes, we all know that in every word problem there's always a statement that will give you a statement that can construct your equation and can support the details of your equation. Now, in this case, for example, let's start with Carlos. For Carlos, yes, for example, this is Carlos. The statement goes like this. Carlos can run in 6 minutes. Oh, if Carlos can run in 6 minutes, so Carlos can run in 6 minutes. We need to convert this statement into what? Into the rate of Carlos. Okay? So Carlos can run in 6 minutes. If we write that into a numerical equivalent, that is equal to what? Mile, 1 mile over 6 minutes. Okay? But if we recall our rate of change, the unit of our rate of change is in mile per hour. It means that we need to convert our given data to hour. Yes. So if we convert that, this is what? In every 60 minutes, there is 1 hour. So what will happen? We cancel minute. The remaining unit is 1 mile. 1 over 6 times 60. So that is equivalent to 10. So the rate of change of Carlos will become 10 mph. Yes, we do the same with Kevin. So Kevin can run 8 miles in 8 minutes. So so let's convert that also into what? To the um numerical equivalent. So 1 mile in 8 minutes. So we multiply it with 60 minutes over 1 hour. That is equal to 15 over 2. 15 over 2 or equal to 7.5 mile per hour. Okay, so we already have the rate of change of Kevin and rate of change of Carlos. So I think we need to write it down. So for Kevin, we have 7.5 and for Carlos, we have 10. Now the time. Based on the statement, on the question, will Carlos catch up with Kevin before he reaches a mile marker? No? Therefore, at this point, their time are equal. So therefore, if we let again, if we let x be what is our statement? That is the time in hours for Carlos to catch up with Kevin. Okay, so that is our x. So that is the time in hour Carlos catch up with Kevin. So both have an equal time, yes. But remember, Kevin start goes out to practice and start a minute before Carlos start here. If this is the starting point of Kevin, it means that at this point, this is a 1 minute difference of Kevin and Carlos. So that 1 minute, we need to convert that minute into hour because our unit for time is in hour. So I hope it's clear. Huh? So if we convert 1 minute, that is what? That is 60 minutes in every hour. So we cancel minute. What will be the uh, answer? That is 1 over 60 hour. Okay, so in our statement, who's ahead? Who consumed the 1 over 60 hour? That is Kevin because he moves ahead of Carlos. Now, if we apply our formula, that will become 7.5 times the quantity x plus 1 over 60. And this is become 10x. Okay, so, and if we write our equation, what will be our equation? Okay, it's clear. Okay, let's write up our equation. Since they have an equal distance traveled at that point. Okay, so if for example, Kevin is our D1 and Carlos is our D2, therefore D1 is equal to D2. So if we write out our equation, we have D1 that is 7.5 quantity x plus 1 over 60 is equal to 10x. Okay, so if we solve simultaneously here, we can determine our x equal to, wait, that is 7.5 quantity x plus 1 over 60 equal to 10x. Shift sub our x is That is 0.05. 0.05. What is the unit of our x? That is in hour. Okay, that is in hour. So it means that it will take 0.05 hour. If you convert it into fraction, just press the SD. If we convert 0.005 into a fraction, that is 1 over 20. Okay, it means that it will take 1 over 20 hour for x for Carlos to catch up with Kevin. Yes, if we try to determine, since the question is, will Carlos catch up with Kevin before he reaches a mile marker? Now, if we substitute the value of our x, which is 0.05, to our distance, okay, so it will take, so that is 10x here, because we're analyzing if Carlos can really catch up with Kevin. Okay, this is 10x, so that is 0.05, that is 1 half. Oh, therefore, it's only 1/2 mile from Carlos will catch up with, which catch up with Kevin. It means that Carlos will catch up with Kevin before Kevin reaches the mile marker. Okay? So the answer is yes. Will Carlos catch up with Kevin? Yes, because Carlos uh, already traveled 1/2 mile compared to Kevin. It's very obvious on the data that he can really catch up. Why? Because he runs 2.5 mile per hour greater compared to Kevin. Okay? So, but the question is, will Carlos can catch up with Kevin before Kevin reaches a mile marker? So the answer is yes. Because it will only take 1/2 mile for Carlos to catch up with Kevin before Kevin reaches the 1 mile marker. I hope that our explanation is clear with our solution. Okay, so let's move to our next example.